went out a little further than mine. I said use as many as yours uses. We are all going to be off by a few cents. Okay, our answer is going to differ by a few pennies.
So should I use yours?
No, use yours. What am I going to do next? Times this by 2 million or raise it to the 12th power? Order of operations, parentheses, exponents, right, first. So this exponent on this number first. So take that. And raise it to the 12th power. So now I have 2 million. And after I raise that to the 12th power, I get 1.02784928. And multiply that times 2 million now. And you get 2,055,698. This is what I got, 0.56. Got a problem there?
How do I get it to not do to the...
To the what? Just take it out of scientific mode. So I went to mode, and I'm just going to go to, well, you're normal. Whoa. Oh, you forgot to, okay, I see what you forgot to do. You forgot to do 1 plus. Look, you forgot to do this. 1 plus that first. And then that to the 12th power. Everybody else get that? All right, so what does that tell you? The interest is $55,698. Okay? Which is, I don't know, if you're happy making $55,000 a year, then you could just sit on your money and make $55,000 a year, just sitting on your money. If you don't spend it, then you make a little more, but not, not a whole lot more. So what would happen to answer that question? What if you didn't touch it for 2 years, right? Then all we would do is change t to 2, which would change this to a 24. Everything else is the same, and we'd figure out how much is there in 2 years. Make sense? Now, what's kind of cool about this formula is that if you add 1 0 to your amount, so instead of winning 2 million on the lotto, what if you won 20 million? Everything would work out the same. You just add 1 more 0 here. So if you won 20 million in the lotto, you would make how much a year? 550,000 a year. Now that's probably enough for you to be happy, right? So these people who make, $20 million, you're basically making $500,000 a year just sitting on your money.
If you have that interest.
But you could get 2.75. If you had that much money, you could do some investments and get that much. Some of it might be risky, but. So let's just play the lotto, right? Think about people who are billionaires, right? So this is like 20 million. If I add another 0, then you're at 200 million, right? How much would you make a year if you won 200 million in the lotto? Not 550,000, it would be 5.5 million. So if you had 200 million in the bank, you would make $5.5 million a year just sitting on your money. So you'd be making, millions of dollars a year sitting on your $1 million. But if you go the other way, if you make this instead of 200,000, or what was it, 2 million? If you make it 200,000, you're only going to make $5,500 off that money a year only. But so it works, but it just seems like more when you start, saying 200 million, you're going to make 5 million a year. The rich get richer. It's the same rate for everyone. Doesn't matter how much money's in there. All right. So if you hear someone wins the lotto and they win $10 million, they're in a good spot, but they're not set for life. That's for sure, because you're going to spend some of that money to start, right? Maybe. All right. Let's do the same problem. Part 2, what if it was compounded, the interest was compounded daily? Everything's the same in the formula except n, right? A will be 2 million, 1 plus 0.0275 over 365 raised to the 365 times 1. Yeah? Take your time with this calculation. What do you think? Do you think we're going to make more money because they're compounding the interest daily? It might be a little more, but it's not going to be much. Was it a little bit more? A couple of cents maybe? $1? Yeah. Yeah, 0.0275. Divide that by 365. So I'm going to do the step-by-step up here. So I did these two together first, got this. I'm going to add 1 and this together. I'm going to raise it to the 365. I'm getting $2,055,761.10. What was it last time on the previous one?
2,698.
698? Oh, I got $70 more or something like that. Look, we're all going to be a little off depending on how we round, but you just don't want to be coming up here and your answer's like, 32 million, something like that, like way off.
So 56.
What did you get here?
I got 56, 59.
59? I would just have to look at your work. What did you get when you did this and put these together? Did you get 1.000 or did you type it all in at one time?
No, I typed it all in there. I got
1.0000, 4 zeros or 3? 4 zeros and then 7 what?
5967.
Okay, so we have a little bit of different rounding error in here. What about, okay, do that again. 0.0275 divided by 365. What did you get?
7.5.
0.34 what?
246,575 e to the negative 5.
Okay, so you used all those numbers? Okay, that's fine. E to the negative 7, you moved it over?
E to the negative 5.
E to the negative 5 and you moved it over?
I didn't touch it.
You just said plus 1? Okay, that's fine. Yep. We'll all have slightly differing answers. It all depends on how much you round. Okay, so we're still in the same ballpark. We're making 55 grand a year off of the money, right? How about if we switch it up, last one, and then we're going to take our little break. What if the interest is compounded continuously? Compounded quote continuously. And I didn't mention that to you. That second formula, this is when you use it, when you see the word continuously in there. So I will be using PERT. I usually can remember that because of the shampoo. PERT Plus. Don't act like you don't use PERT Plus. Old school. They have a new, refreshing design. No, I'm kidding. All right, so the formula is going to be 2 million e to the r, what's the rate? 0.0275 times t, which is 1 still, right? When you do this, figure out what this is first, which in this case is easy because it's just times 1, right? Do e to that power. After that, multiply by 2 million. So e to the 0.0275. So I'm getting 2 million times 1.027881615. $2055763.23. $55,763.23, give or take. That was a little easier to calculate, right? It was a little cleaner on the calculator, which is part of the reason why this is a preferred formula. It's a lot cleaner and easier to work with.
So the only time for this one is if it says continuous.
Yes, and that's what most banks do. They do continuous compounding, which makes you think, oh, wow, you know, that's great for me, but it really doesn't make a big difference, okay?
It sounds nice.
Yeah, it sounds nice. Now, the more interesting question, this is where we're going to cut it off and we're going to say this is the last bit of material for what's going to be on the test on Monday. We'll cut it right here. But next week, what I plan to do is something more interesting, which is what if we won $2 million and we went and put it into a bank and we went and put it, it had an interest rate of 2.75, same situation. And I wanted to know how long it was going to take to turn it into $3 million, right? The way that the formula would change would be what the amount that we want at the end is 3 million. The amount that we put in initially is that much. The interest rate is 0.0275, but time is the thing that we want to know, right? The question becomes, how do you solve for t in an equation like this? We've never had this before. We have never had the variable we're trying to solve for stuck upstairs in an exponent before. It's always been on the bottom. So like linear equations, we move things over, we divide through. Quadratic equations, we had a formula, right? Rational equations, we can like clear fractions, and there's methods. But for this, we've never faced it. And there's a certain process. And by the end of next week, my hope is that we can solve these types of equations. All right? All right, we're going to take a little break. Let's just make it an 8-minute break. It's 1:52 on my clock. We'll come back at 2. And we'll talk about the test.
So bright and shiny.
It was quite the sacrifice, but I had to do something. Sacrifice for $100. Actually, like $380 for the case too.
Yes?
Is there a reason why quiz 2 is blank on here?
I put too many quizzes in there on accident, and I realized it after, because when I was grading, I graded from the last one backwards, and I put too many in there. So yeah, everybody, it's blank for everyone. I'll fix it. I just didn't have time to take it out of there. Rename everything and stuff. So.
Will we ever have like a random test quiz?
What?
Will we ever have like a random test quiz?
Rather, yeah, let's do a random name tag quiz.
Right now?
How we could fill in quiz today.
Yeah. Yeah, but you're supposed to have it out already.
It's there.
I forget.
The point of a random name tag quiz is that it's random and that I don't tell you, I'm about to have a quiz on your name tag, so if you don't take it out, take it out.
Don't you deal with logs whenever you try to find?
That's right, we have to introduce logarithms, which basically is the inverse of an exponential function. So, yeah, it undoes it. Yep.
Are we going to do anything with half-lot?
Well, that's one application we could have done with the exponentials. We probably would have talked half-life had I not canceled class yesterday. What's wrong with half-life?
Half-life is complicated.
No, it's not.
Well, the way I was taught.
Yeah, it doesn't have to be complicated. It doesn't have to be complicated. It's really, yeah, it doesn't have to. Yeah. In fact, you know, this exponential function that we just did right here, 1/2 to the x, that's a very generic half-life formula. Because what's happening is that you're starting out, when we graphed it just a second ago, we were at 0, 1. And then after 1, at 1 we were at 1/2. And then we were at 1/4. Okay? And so what happens is every step in time, half of it goes away. And that's what a half-life is. The only difference between the more general half-life problems is that this measurement of how long this takes changes. So instead of it being 1 year for it to go away, this could be 10 years, it could be 1,000 years. And so the formula, we tweak it a little bit. We put another little constant up here, k. And we could do that, but it's just an extension of what we've done. So it might just be the way it was presented to you, that it seemed more complicated.
Like, you start in year 20, whatever, and then you have a half-life of so many years.
Mhm.
So what will the half-life be at the year
Or how much would be present?
50, whatever?
Yeah. So you have to come up with your constant first, your decay constant. You have to figure out what that is first. Then you come up with the function. Then once you have the function, you plug in the year, and you've got how much is there.
Can't even remember that.
Hey, so you learned something. That's great.
I love it.
I was looking at it yesterday on Besides college algebra. I don't like it as I can check college algebra there. But other
Since it
than
won't
that.
back up. Yeah.
It's 6 hours.
I feel like this Wi-Fi's not strong enough.
It's almost smaller, even though it's university. It's a little. I know that sounds crazy, but that's what it does, 'cause it's small, even with all the dorms and intermingle and all that. If you ever decide to come check it out, seriously, find it. Yeah. Yeah, their nursing is awesome. I mean, it's not necessary. It's more dry, there's more of a winter.
Nothing regular. I've been a headache for 4 days straight. I've been popping Tylenol and I'm waking up every day with headaches.
And you're really close to a woman.
And I took a PM, but I guess my body doesn't really like them.
Does that say 6x to the 5th?
Yeah, to the 5th.
and then there are parts of a.
Yes, turn it on, but go to your details.
Like my says?
No. Like, you go tweet, so whoever is sending it to, you go to their house messages.
Oh, go over there.
And then you have a safe contact. And then underneath that, they send my current location share, and I can take your campus or what. And then you say, and I just more, so.
A lot of them are. The nursing classes are in what we call the fancy building. It has like there's even like there's a
It's so weird, like being able to see. Yeah, like, it's weird. It's like, when people at Apple Store or like, so wait, it's
They thought you were hacking it.
just like, oh, it could be like, so not just like, but screen lighting up.
This would be a quiz.
Yes.
You notice there's a 0 for one of the quizzes?
Quiz 2?
No,
No?
no, they didn't do. It was the one with the falling object.
Mm-hmm. Oh, well, did you not do it?
No, I didn't.
Well, I had some that didn't have
Yeah,
names.
I checked it. Was right.
It wasn't it?
Mm-mm.
That was mine.
And you turned it in?
Yeah. So I remember doing it because that was the day like I had to leave early. Remember, and then I had to watch that on
Yeah.
the video.
Did you turn it in separately? Or do you turn?
Probably.
Okay, let me go back through my paperwork and see if I can find it.
Okay.
Right now, I can't say where it is.
Sure.
Okay.
I know.
All of these problems are sketch, 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 sketch. Okay, so I put up some problems here, and I'm going to get the camera and kind of zoom in on them so people that want to rewatch this will have a copy. Well, my focus is all out of whack. Okay, there's the first one. Don't worry, you're not on camera. I'm zoomed in pretty good. 2, 3, 4, 5, 6, 7, and 8. All right, so I'm going to turn off the recorder, I think, because there's no way I guess I'll leave it on. I'm just going to do these. Yeah, I'll do it after I finish everything. I'll come back and video it. All right, so look, because time, we only have, 35 minutes. I think most of the requests that we have are for these rational functions. Is that fair? Or is there something specific you want me to focus on? I mean, this is it. You're looking at the test. Right up here, this is the basic idea, except the compound interest problems with the money, which will be just like the lottery winner, okay? I'll give you the person has a certain amount of money. You can calculate how much is there after a certain amount of time. Yes? No? Yeah, let's talk cheat sheets. We're just going to do the same thing we've done before. I don't want to change it up. So if you want to use a cheat sheet, 5 points off. If you don't, no penalty. But I'm not going to provide you with any of the formulas. hurt, and then the other one you need to know. So if you can memorize those, and then when you start test, you're free to write them down on the test. That's okay. That's what I used to do because I'm not a big memorizer. Is I would just remember them right before a test. They would hand out tests. I would just write them all down. So you're okay to do that. But these have all these steps, right? These have all those steps in them. And if you aren't going to be able to remember the steps, then you might just take the 5-point hit and just come up with this big cheat sheet. Okay?
So testing all the, like that
Plus the money, yes. I'm not saying it's going to be the same length as this, but this is the variety of problems you're going to see.
Are you going to work them out?
Yeah, right now, I don't have time to do all of them. So that's why I wanted you to tell me what you wanted me to focus on.
Do one of each.
You want to do one of each?
Yeah.
Okay, so you pick 1 through 3 are basically the same. Okay, look at them for a second. 2, okay, I think 2 in my opinion would be not the hardest, but that negative out front is what gets most people. I graded a lot of the work that y'all did on these graphs, and a lot of people missed that negative. Okay, so here's what I would do here. This is a polynomial. Right, I'm doing my steps. It's a polynomial function. Because it's a polynomial function, the second step is to do left-right behavior. Left-right behavior. What's the degree of this polynomial? 5. That's odd. What's the leading coefficient of this polynomial? -1. That's negative. And what does your polynomial function look like left and right when you have odd and negative? Left up, right down. Pardon?
Why'd you put n instead of
N is the degree. We called it n. Yeah. We said the degree of the polynomial is n, which is 5. And so we got that. What's the third step? X intercepts, right? And this is where we're going to determine if we bounce or if we cross, right? But we have to take the original polynomial and set it equal to 0. So in an effort to maintain some room here, I'm going to take negative x to the 5th plus 5x to the 4th plus 14x cubed, set it to 0. And always when factoring, the first step is GCF, right? Always try and pull a GCF. So we can pull an x cubed out, right? I recommend a negative x cubed. Anytime your leading term is negative, it throws off your factoring. So pull a negative x cubed out. So if I pull a negative x cubed, I will have to rewrite what's left, but everything, the signs are going to be opposite of what was there. So what would be here? X squared, but positive, right? The next one will be negative, 5x. And the next one will be minus 14. And then you have to try and break down that quadratic. So this is where you might make that little x over here. AC method, the numbers we're working with are 1 times negative 14. So negative 14 up here and 1 here. What two numbers multiply to be negative 14? Why did I put 1? I have no idea why I did that. Sorry. Negative 5 here. Multiply to be negative 14, add up to be negative 5. Negative 7, positive 2. And then you go through and you do it, all right? However, you could do the grouping that we did in class, or I'm not going to take time to show that step. I'm just going to assume everyone could get to this. It'll be x minus 7, x plus 2 equals 0. Now you set each of those factors equal to 0. So when you set this to 0, what do you get when you set that to 0? What's negative x cubed equals 0? 0. Right? The only number you can cube and get 0 is 0. So x is 0 is the answer here. How about this next one? When you set x minus 7 equal to 0? Positive 7. So again, notice that on some of your take-home stuff, your signs were off on this. This is going to give you positive 7 as an x-intercept. And this one will give you negative 2. What should I be thinking of next? Yeah, is it going to bounce or cross? Before I draw it, I need to determine if it bounces or crosses. So let's look at this one right here. I'm going to cross. Why? Because the power is odd. So I'm going to cross. I'm just going to put a C here. What about at 7? Cross, because the power here, 1 is odd. Cross. Factor here, 1 odd, cross. Crossing at all x-intercepts. No bouncing going on here. Now I'm ready to draw. Starting with the x-intercepts. Put those on there first. I was pretty harsh on the grading for the quiz, the take-home quiz, because number one, it was take-home. And number two, I really wanted you to feel like if you were wrong, like it was wrong. Like you can't be that wrong during the test. All right, those are my x-intercepts. What do I do next? The left and right behavior, right? The left and right behavior. So I'm going to start, I know it goes up on the left and down on the right. So I start with my leftmost point, and I just draw up from here, my rightmost point down. And just keeping in mind that as I draw the whole thing, I'm crossing through all x-intercepts. So up on the left, it's going to cross through, it's got to get back to this point and cross through again. Can I go way up here like this? Sure, I can do whatever I want up there. Then I can come back down and cross through and go like that. That's it. That one's done. All right, what else would you like me to do? Do you want me to do another one of the polynomials, or? What do you got? Taking requests. 5?
6.
5, 6. I think I'll have time to do both. So let me do 5 first. So for 5, I have what type of function here? Rational function. So since it's a rational function, I have a whole slew of steps. I think there's 7 of them, right? So after identifying what it is, I'm going to find what? X-intercepts. And to do that, numerator equal to 0. Solving, you should get 2. Move the 6 over, divide by 3, you're done. That's going to be a point that lives on the x-axis, right? What's the next step? Vertical asymptotes. How do we find those? Set the denominator equal to 0. How do you factor that? GCF, x. Pull an x out, you're left with x minus 6 equals 0. Set both factors equal to 0. That was another thing I saw in the take-home stuff, is that there's just this tendency for people to forget about the x. I guess because it's just out there by itself, it's not like x minus 2, they just forget about it. And if you miss it, you're going to miss an entire vertical dotted line, and your picture's going to be all wrong. So set this one equal to 0, you get 0. The other one equal to 0, you get 6, right? These are vertical dotted barriers that I cannot cross. When my function gets to those barriers, it's going to go up or it's going to go down. That's what I know. All right, 4th step, horizontal. Now, I only did 2 of the 3 cases that are possible. And so which case is this one? This is case B, right? So what are we looking at for the cases, for the horizontals? What are you actually focusing your attention on? The exponents, right? The power of the top, which is 1, and the power of the bottom here, which is 2. The degree. Case B was cab. Case B was when the numerator's degree was smaller than the denominator. 1 is smaller than 2, so we have case B. Case A is what? When they're the same, right? Okay. Case B, and what is case B? What do we get? Y equals 0, which is the same as the x-axis, right? This is the only time that it's the x-axis. We draw this only at the ends, dotted lines, only at the ends, and those pull our function down towards them at the edges. That's what it does. Yes?
For case B, is it all like the rewind?
Yes. What's next? Plot all the information, right? Was it only 5 steps?
Yeah.
Okay, 5. Why was I thinking 7 steps?
Because the other one was
That's weird.
that was fun.
Where?
I'm thinking out loud, sorry.
Okay. All right, so here comes my graph. Starting with the X intercepts, I only have 1. It happens at 2. I put a dot there. Vertical asymptotes at 0 and at 6. The one at 6 is easy to draw. The one at 0, I said to do those like diagonal dashes.
Are you okay with this format of graph where you don't have to put every line to represent the number?
Oh yeah, I'm okay with that. Yep. But you just wouldn't want to put, obviously, 6 here and 2 there. Like, it has to be in the right order, yeah. Or right next to each other, it just wouldn't look right. Okay, that good? What's next? Horizontal. So let me put this horizontal on here. And that I only draw at the edges. I don't have to go all the way out here, but I may as well. Now the test points, I think, are the next step, but I think there's still some confusion on the test points. All you look at are the vertical asymptotes and the X intercepts. And what you need is one test point only between each X intercept and vertical asymptote, just one test point, and you have to have them on each side. So if you want to visualize this a little different, here's your graph, right? Now just trying to visualize here. I have a vertical at 0, an X-intercept at 2, and a vertical at 6, right? That's what I have. I need to basically have 1, 2, 3, 4 test points. Anything here, 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 and here. Any number you want. So when I go look to the left of 0, -1's the first thing that pops in my mind. I'm going to put it there. You can even mark it with a little x. I just told you don't put a dot, right? So -1 I'm going to test. I'm going to write down what I'm going to test here. Test, -1. What else am I going to test? 1. What else? 3, 5, 4, right? Any of those would work. I think I heard 3 first. And finally, something out here, 7. And all we're really trying to determine from these points is whether or not we're going to draw a dot above or below the x-axis. That's all that matters. So let's do -1. And I'm plugging this into this, right? All right, so here comes -1. F of -1 is 3 times -1 minus 6 over -1 squared minus 6 times -1. What does the numerator become? The numerator? -3 minus 6, -9. The denominator, 1. Negative, negative is plus. So 1 plus 6, 7. And then I can figure that out as a decimal. But more importantly, it's negative, right? So it's below the x-axis. So you really do not have to worry too much about how far this goes, just as long as it's below. For the same reason polynomials, we didn't care how high and low they went, right? How about at 1? Three times 1 minus 6 over 1 squared minus 6 times 1. What's my numerator? 3 take away 6, negative 3. 1 take away 6, negative 5. Negative over negative? Positive. So I know it's above the x-axis. Anywhere I want. Good enough. Bless you. Now plug in 3. This is tedious work, but it's important work, because if one of these is off, then your picture is going to be off. 3 times 3 minus 6 over 3 squared minus 6 times 3. So on top, 9 minus 6, 3. And then 9 minus 18, negative 9. It's negative. And for 7, I'm not going to show the work. It turns out to be positive. Now the drawing phase of this. How many of you feel uncomfortable with the drawing part? Feel a little weird about it? Okay. The way you have to look at the drawing is that for every dot that you have on here, for every point, you must, out of that point, must come 2 arms. One to the left, one to the right. And you just have to figure out where those little arms are going to go. All right? So for like this point, I need an arm to go out this way, which is part of the graph. And can you tell me about anything that that arm must do? It must not cross here, but that blue dotted line is more than just a barrier. It's actually acting like a magnet, right? It's pulling you towards it. See, it's different than this. The horizontal ones pull you towards it. So it says, all right, I must go towards the light that way. And then you need a little arm coming out of the right side of that dot. And the question is, where does it have to go? Well, there's this barrier, right? It forces you up or down. And just to kind of simplify things, if you want to know if you're going to go down or up, all you have to really look at is whether or not you're above or below the x-axis. If you're below the x-axis, you're going to go down. If you're above, you're going to go up. So I'm below the x-axis, I'm going to go down. That. And that's it. I have to pick up my pencil and move to the next dot and do the same thing. So left to right, like you read a book. This little dot here, left side, left little arm coming out, it's going to have to go where? Up because of the barrier. And then out the right side, what's it going to have to do? It's got to go down to this point, right? So I know, I'm going to try and make this look nice and smooth. It's going to go up like this. It's going to connect the dots here. And then out of this dot to the right, it's got to get to this one. So it's just going to cross through there. And then outside the right side of this one, you've got the barrier in front of you again. So you've got to go down. Pick up your pencil, move to the last dot, to the left, up, to the right, magnetic line pulls you down toward it. That's it. We good? Okay. You want me to do 6? Was that the other one? 6? Okay. Let's make 6 a little uglier, just for fun. Just to show you that, I could do this on the test. It wouldn't be out of the realm of, well, no, you know what? That one had X intercept. as a horizontal? I mean, sorry, x-axis. This one doesn't, so I'll stick with it the way it is. All right, so doing this one, first step, is it a rational function? Yes, okay, so it's rational. All right, second thing is to determine the x-intercepts. So you have to set the numerator equal to 0. And factor. So how would you factor that? I would take out a 2 first. It might make it a little easier to work with. Factor out a 2. GCF of 2. And then you have to factor x squared plus x minus 20. So you'd make a little table over here. Negative 20 and 1, positive 5 and negative 4. Then you go through the steps and you factor it out.
Is that 2?
Yeah, let's talk about this too. Let me finish this part up first. You get that. Is that okay? Now you're supposed to set each factor equal to 0, right? Set each one equal to 0. You have 3 factors. This, and this. These two, most people have no problem with. X plus 5 equals 0. You get x is negative 5. This one, x minus 4 equals 0. X is 4. We're all good to go. The big mistake I see people make is they'll say this over here, x is equal to 2. And that's incorrect. What you're actually trying to say is when does 2 equal what? 0. And it doesn't. Okay? This does not have a variable in it. This could be 0, right? If you let x be negative 5. This could be 0 if you let x be 4. This can't be 0. So it's not going to affect any of your answers. You're only going to have 2 answers. Here they are. Okay? So this, just throw it out. If you don't like that explanation, you could divide both sides of this equation by 2. This is a 1. 0 divided by 2 is still 0. So you're basically at this times this is 0, and you get those 2 answers only. All right, x-intercepts done. Third step, verticals. Set the bottom to 0. I think it's clear you're going to have to be able to factor a quadratic, right? That's pretty clear? X plus 3, x minus 2 equals 0. So I'm not showing the steps here. Just get to that. You'll get 2 answers, negative 3 and positive 2. Next step, horizontal asymptotes. What case do we have here? Case A? Case... Case A. Case A because they both have the same power, right? So in this case, you look at the numbers in front of the x squared. 2 and a 1, right? And you say y equals 2 over 1, which is 2. And that's everything I need. I can start drawing it now. Draw it over here. All right, start with my x-intercepts, negative 5 and 4. What am I going to draw at these? What am I putting there? Points, right? Those are points, x-intercepts. And next thing was verticals at 2 and negative 3. How many test points am I going to have? 5. 5. I have 2 X intercepts. I have 2 verticals. That totals 4. Add 1 to that. The horizontals have nothing to do with how many test points you're going to have. That's just the rule of thumb. Yeah. Because if you look at it this way, if I break up the number line into 4 sections, then I'm going to need 1, 2, 3, 4, 5 points to test the 4 sections. Or actually, breaking the number line into by 4 points like this creates 5 sections. Just like if you take something, cut it in half, you create 2 sections. 2 cuts would give you 3 sections. Yeah, that makes sense? Okay. All right, so you ready for test points? Let's list them out, what we want for our test points. Oh, no, I forgot my horizontal. Oops, horizontal. Now, I didn't put my y-axis on here. You don't have to. I'll put it in here, though. There's somewhere in there. And I go up to, and I draw my horizontal only out at the edges, right? Only at the ends. So I'm just going to come out here, right about here. I'll just, there you go. And then over this way, like somewhere around here. Good enough. Test points. Who wants to give me some test points here? What's that? -6 will work. -4 is a good one, so -6, -4. 0 is a good one. I like 0. 0 is usually fun to plug in. 3 will work, and 5. Remember, I'm distinguishing these test points with little x's because I don't want to start putting all these dots in here and get confused when I'm drawing this later. All right, can I say that you should be able to plug those in yourself? Yes? Okay, so here's what's going to happen. You're going to get a positive. You're going to get a positive number when you plug this in. It's going to be bigger than 2, so it's going to go up here. And then you're going to get -4, it's going to be negative. And then you're going to get over here at 0, you should get a positive. And actually, it's going to be way up here like this. And then here you're going to have a negative. And then here you're going to have a positive like that. That's what would happen. I'm not going to go through all that work. Now, there was something I was going to tell you, but I can't remember now. What was I going to say? Oh, yes, I remember. You may be picking up on a pattern that once you have that first one, they keep switching, right? That does not always happen. If it did, I would have told you that to begin with. All right, but it doesn't, so that's why you have to test each one. I could give you a problem up here where that would not happen. It would not switch back and forth. So we have to go do the long way. All right, let's start with that leftmost point, which is here, and draw the 2 little arms coming out. To the left, what has to happen? Towards this magnetic dotted line here, like this. Just like that, that's good enough. To the right, oh wow, you know what? I think this point is actually going to be below. It doesn't matter though. I've got to go from here to here. Right? There's a dot right there. I've got to go. So I'll just turn it back like this. That's fine. What? What's wrong?
You're joking, right?
No, I'm not. Why? What's wrong with that?
Are you serious?
Yeah.
That doesn't work.
Why doesn't that work? Why doesn't this work?
Because you're crossing.
Crossing what? This? Oh, don't remember. The horizontal only tells you what happens at the edges. That's why I told you don't draw it across. You watched that YouTube video, right? You came to my office this morning. You had that dotted line all the way across. You got that off YouTube? Don't draw your dotted lines all the way across. It only tells you what happens at the edges. Look, at this point to the left, it should flatten out to this. This direction, The dotted line's not there. You're allowed to go down. That's okay. In fact, I have to go from here to here. Okay?
Okay.
You all look confused now.
Yeah.
We never had one that's like.
Switch it up.
Follow the dots and use the information. Right? I've got to flatten out towards this line as I go to the left. To the right, I've got to go from that dot to that dot. Do not draw your horizontal line all the way across, or you will start to confuse yourself. Where am I going from this dot? Down to this one. And where am I going from that dot? Down this way, right? That you cannot cross. That is always a barrier the whole way up and down. You're not allowed to pass through it.
So we can only.
This, just imagine that this is just like a vacuum cleaner out here, just like as you're trying to do something that's pulling you in, you have no choice. If you turn back and go the other direction, you're free to do whatever you want. Okay? That's what's happening there.
So is that really the direction it would go?
If you graph this on a computer, it's probably going to do this. Okay? Yeah, it just, I mean, look, remember, we said we don't care how high or what happens with this because we can't tell anyway. If I'm just using my test points, then that's what I would have. I wouldn't count that wrong, no. All right, down here, jump over, pick up your pencil, next point right there. What there? Up and what? Up and down? So to the left, I'm going to run into a barrier. You're telling me I have to go up. I agree with that. The reason you can't go down is because you can't cross through, right? What about to the right? You want to go down because everything else we've done went down, right?
You gotta keep going up.
I've got to go turn back up again. Why not? Why can't you do this? There's no X intercept down there. This is what you have to do. See, this is why this graphing is not about just like I show you a few and then every time you do it, you know it's going to look like this. Like it's always going to look like that. No, each one of them you have to be following the information to be able to come up to determine the graph. All right, that's that. And then now next one. Here's the dot. To the left, what? Has to go down. And then what? Connect these dots. And then it's getting pulled over here like that. That's it. All right, so along with the polynomial and the rational functions, you'll have to graph these, which you just do a little t-table. What numbers are you going to plug into this? -3, -2, -1, 0, 1, 2, 3 for both of those. And then the word problem on the interest. Yes?
You're not going to do an application problem on volume, are you?
I don't see that happening. I gave it as a take-home quiz, so I'm okay with that.
Do you want to sit
If you, yes, I'm not giving you anything for this test. So if you know you're going to need to reference that table, then you're going to need to have a cheat sheet. One sheet of paper, front and back. That's it.
So like we're factoring, like I get the like factoring part, but like